Welcome. We are Yujin Jung and Jonghyun Lee, the developers of Fita, a project of virtual fire drill in mixed reality. Our project focuses on fire drills. At their core, fire drills are mental people practice the procedures they would need in a real emergency. So ideally, it should require a realistic setting, evacuees' own judgments, and the usage of equipment throughout the process. But let's think about the actual fire drills we've experienced before. There's nothing more than the sound of a fire alarm. We mostly follow an instructor passively, and in many cases, we do not get a real chance to learn about the equipment such as fire extinguishers. With these fire drills, where realism and immersion are limited, it's difficult for people to become familiar with fire situations that require quick judgment across different scenarios. So, we decided to develop a fire drill with a virtual experience. Instead of fully virtual one, we added a virtual fire layer on the real-world physical spaces we actually live in, which called as mixed reality. Our project needed to satisfy four main requirements. First, creating virtual fire environment based on a real world. Second, allowing users to move freely and make their own decisions rather than simply following a fixed path. Third, providing partial guidance on procedures and equipment. The last, availability of multiple users participating at the same time while the entire situation controlled from a central system. For the head-mounted device, we used MetaQuest, which is a strong ecosystem of libraries and open sources. Then, we implemented the mixed reality with Unity engine. Database with MySQL contains information such as players, their logs, indoor coordinates, and so on. The algorithms handling the entire fire simulation are implemented with Fast API. Also, we post-trained the YOLO version 8 nano model to analyze the user's real-time camera frames for event triggering. For this fire drill, we used 2 floors of the actual building, and 2 players go through the drill together through our service Fita. One player who notices the fire early starts on the upper floor of the building. The other player who notices the fire later stays on the lower floor. The fire starts near the elevator and spreads toward the upper floor. Both players try to evacuate through the same exit on the lower floor. This evacuation process will be shown alongside the 6 main features. The first part is the initialization. This is where each evacuee registers ID and current location into the system for the initial values and states of the drill. The second part is the virtual fire. This covers how a fire in a random location starts and spreads through the building. The third part is tracking location. This tracks the user's real-time indoor location and calculates the shortest evacuation route. The fourth part is detection and events. This recognizes objects within the user's field of view and triggers events during the evacuation. The fifth part is user state. This recognizes a risky state and sends alerts, such as being in a panic or trying to use the elevator. The last part is ending feature, which provides evacuation feedback after users complete the drill. First, in the initial stage, the user enters their current floor and their user ID. This information is sent separately to the server and to MetaCloud to set up the initial conditions. To server, both the user ID and the current floor are sent. The server verifies whether the user ID is a registered user, and based on the current floor, it calculates the user's distance from the fire and assigns a different golden time for each other. To MetaCloud, the system sends the GUID that corresponds to user's current floor. Here, a GUID is an identifier for a group of spatial anchors. A spatial anchor is a coordinate system that allows the same virtual object to appear in the same real-world location every time. Because spatial anchors recognize visual feature points in the surrounding physical environment and store them on the device, they can be restored to the same real-world location across different sessions, or even after the device has been rebooted. MetaCloud uses GUIDs to store and share spatial anchors as groups. This allows spatial anchors to be shared between users running the same application. And since these anchors remain almost fixed in the real-world position where they were initially installed, we can map the actual building onto a virtual layer. This becomes the foundation that allows Fita to support multiplayer interaction as well as location tracking for each individual user.
Fire starts randomly at one of the building anchors. Using a spreading algorithm, the ideas of 6 anchors are added to a list. 4 adjacent points on the same floor, and 2 vertically adjacent points on the floors above and below. The system iterates through this list to spread the fire recursively. This process runs in the background and updates the database. Users receive the list of affected anchors via an asynchronous function. The interface displays fire effects at these locations, followed by smoke effects after a few seconds. Evacuation routes change based on the user's anchor ID. If an exit exists on that floor, it is set as the goal. If not, a staircase landing on the floor below is dynamically assigned. The user's location is logged in the database in real time. When an anchor connects to a landing, the system returns a GUID to the local device to allow for reconnection. The local client calculates the vector3-based distance to the target and sends it to the server. If the distance to the goal increases, an alarm warns the user that they have left the path.
The fourth feature is detection and events. This feature detects the fire-related objects the user is looking at during the fire drill and allows the user to interact with those objects in the mixed reality environment. So when the user looks at real-world objects such as faucet, fire hydrants, and extinguishers, our system recognizes it and brings up a virtual interactable object on top of the real environment. In this part of the video, the player notices that the fire is spreading and uses a virtual fire extinguisher to put out the fire. Also, when the user looks at a faucet, they can prepare a wet towel for breathing. At that moment, the server recognizes the action and adds extra golden time for the player. This process follows the sequence shown in this diagram. First, the camera frame captured from the player's meta quest is coded in base64 and sent to the server. Then, the server runs the object detection using our fine-tuned model. After that, the detection result is sent back to the player's device, and the device displays a 3D object in the user's field of view. For the object detection model, we use Ultralytics YOLO version 8 Nano model to recognize 3 types of objects: faucets, fire extinguishers, and fire hydrants. To fine-tune the model, we collected around 650 images of these objects from the actual building where our project takes place.
During the evacuation, the system monitors user status and location in real time to trigger various event notifications. If a user stops moving, the system identifies it as a panic state and reduces the remaining golden time. If the user current anchor catches fire, a no passage alarm is displayed. If that anchor is an elevator type, a warning is sent to the user to avoid using the elevator.
The final feature is ending, which provides a brief report once the evacuation is completed. When the player has reached the exit tracked by the server, a completion status is sent to the device. Receiving this status, the device displays the result screen using the cached data during the drill, including the count for each event, the remaining golden time, and the user's ID. Throughout the development period of Fita, we conducted multiple rounds of user testing and interviews. Through these sessions, we were able to confirm the value and significance of the project. Users who participated in the tests felt a strong sense of immersion and realism from seeing a fire situation unfold in a familiar, real-world space. They showed particular interest in using fire extinguishers and indoor fire hydrants through 3D interactive objects. Therefore, the Fita project holds the following significance. First, we were able to provide a more immersive fire drill experience. Second, we confirmed that learning how to use fire-related equipment through 3D objects can leave a strong impression on participants. Third, participants were able to evacuate freely under randomized scenarios rather than following a fixed path. Fourth, multiple participants were able to play and evacuate at the same time. Fita was developed by backend developer Yujin Jung, front-end and machine learning developer Jonghyun Lee. The project was advised by Professor Gukjin Jang. Thank you for watching our project.